Okay, good morning. Okay, let's talk about molality and freezing point depression. Um, and I thought to do this, I'll just go through some of the problems in the study guide and just kind of show you, the step-by-step approach to each problem. All right, so let's try number one. Number one is pretty straightforward. This is just a straight molality problem, and the first thing that you gotta know is the definition of molality. So let's just write that down so that we are agreed to what that means. Okay, so molality by definition is it's one way of defining the concentration of a solution. Okay, and so it's just basically the amount of stuff that you've dissolved in a solution per amount per quantity of solvent. And so for molality specifically, it's the number of moles of solute divided by the number of kilograms of solvent. All right. So if we, with that definition in front of us, when we read the problem, it says there's a solution that contains 527.2 grams of potassium nitrate, and it's dissolved in 4.47 kilograms of water. All right. So the water is the solvent in this case, and the potassium nitrate is the solute. All right. So when we look back at the definition of molality, you can see that we're going to have to, unfortunately, the problem didn't provide us with the number of moles of solute right off the bat. We are going to have to calculate that ourselves. All right, but that's no problem. That's just a mass to moles conversion, and then we'll have moles. But the problem gives us the kilograms of solvent. It puts it right over the plate, so that's easy. So really, our only task is to simply convert this amount of grams of solute to moles. So to do that, you're going to need the molar mass of potassium nitrate. So hopefully, pause the video if you haven't done it. Make sure you know how to figure that out. But if you did that, the molar mass is 101.11 grams. Okay, and that's per mole. All right, so you should get, for number of moles, you should get 5.214. 5.214 moles, okay, of potassium nitrate. All right, so now that we know the number of moles, we can come over here and simply fill this stuff in. So we have 5.214 moles of solute, and we have dissolved that in 4.47 kilograms of water. And when you divide those two things, you should get 1.17, and that's moles per kilogram, right? I'm just following the units from above. And by definition, moles per kilogram in chemistry is the same as molal, which we use the lowercase m to symbolize molality. All right, so there you go. That's how we would approach a problem like number one. Okay, so let's go down. What about number two? Okay, so again, same thing. When you're doing a molality problem, it's really good to have the definition over here somewhere, like up in the corner. So now I'm going to abbreviate this a little bit. I'm going to say, moles over kilograms. And I might abbreviate this just a little bit further by using the symbol for molality. All right. So in the context of these kind of problems, the lowercase m, we're going to remember that that means molality, and that is equal to the number of moles of solute divided by the number of kilograms of solvent. All right, so this will be a nice little reference for us. Okay, so let's read the problem. It's asking us what mass of barium chloride must be used to make a 0.35 molal solution that contains 750 grams of water. All right, so I think, so, what's the solute and what's the solvent in this problem? Do you know what the solute is? It's so hopefully you identified the barium chloride as the solute, and the water is the solvent in this case. Okay, now, so the first thing, we look over here at our definition, and we might, we're not always going to be given information to allow us to calculate the moles of solute. It may be that we are provided the I'm sorry, let me back up. We may not always be calculating the molality. We may be asked to calculate how many moles. Okay, so I need, we need to be flexible with our thinking. Depending on the problem, we may need to do a little algebra on this problem and solve for moles, because the problem may give us molality, like it does in this case, right? We know it's 0.35 molal. And we essentially know how many kilograms of water we have, right? It tells us we have 750 grams, so right off the bat we know the molality is 0.35, and we know the kilograms of water. So you can easily convert 750 grams to kilograms, right? So that's, when you do that, you'll get 0.750 kilograms. All right, so we know everything except for the number of moles. This is what we need to solve for. Okay, so when you do that, you're going to get moles equals molality times the kilograms of solvent. Okay, and so let's go ahead and let's put the numbers in, okay, from the problem. And when we do that, we'll know the number of moles of barium chloride that are required to make this concentration of solution. And then, in order to get the actual mass, we know it's just a small, easy conversion from moles to mass, right? We can do that. We've done that a lot. All right, so let's just plug in. So we got 0.35 molal times 0.750 kilograms, and that equals, let's see, what did I get? 0.263 moles. Okay, so that's how many moles of barium chloride. Now, in order to get mass, so the mass is equal to the number of moles times the molar mass. All right, so we have 0.263, and that's moles times, and the molar mass of barium chloride is 208. Hopefully you make sure you remember how to derive the molar mass, and that's grams per mole. And when you crank that through, you'll get 54.7 grams of barium chloride. Okay. All right. So just kind of reviewing the problem. As I say, on these kind of problems, start with the definition. Write the definition of molality down somewhere in your workspace so that you can refer to it. And then, depending on the wording of the problem, you may be solving for either molality or the number of moles or the number of grams, or you may be solving for the number of kilograms of solvent. All right, so you have to be ready to solve for any one of these three. And once we got moles, in order to answer the question, which was asking for mass, we had to do a simple moles to mass conversion. Okay, all right, let's see what's next. Okay, so here's yet third variation on this, but a small one. All right, so again, I'll put my definition up here. Molality equals number of moles divided by kilograms of solvent. Whoops, I didn't mean to cross that out. Okay, what is the mass of water? So that's what we're solving for, to make that molality solution that contains this many grams of solute. Okay, so the sodium hydroxide is the solute in this case. All right, so we are going to be solving for this, so we need to isolate the number of kilograms of water, and so that's just moles over molality. All right, and let's see, so we have to do so this is moles of solute, right? The problem didn't tell us how many moles, it told us how many grams, so we need to do a mass to moles conversion real quick. The molar mass of, let me go down here and do this. So the number of moles of sodium hydroxide is equal to the mass of the sample divided by the molar mass, which I'll abbreviate as mm. Okay, so that's 328.1 grams over the molar mass. You should get 40.00, and that's grams per mole. And when you crank that through, you'll get, let's see, what did I get? Oh, I beg your pardon, I didn't get that one calculated ahead of time. Divided by 40. All right, so you should get 8.220. 8.20, and that's moles, right? Okay, so now we know how many moles of sodium hydroxide we have. So we just put that into our expression. We know we have a 1.35 molal solution, and just to be really, I'm going to be very explicit with my units here. Remember that molality is moles per kilogram. So I'm going to break that out. Instead of writing M for molality, I'm going to break this out into moles per kilogram so that you can really see what's going on with the units. Your final answer here will be 6.08. And hopefully you can see that the moles cancel. You have kilograms in the denominator of the denominator, so you're going to get kilograms as your unit, your final unit. Okay? All right. So hopefully this gives you a little bit of help on the molality problems. Now let's tackle a few freezing point depression problems, and I'm going to I don't want this video to be too long, so I'm going to stop here, and then in the next video we'll do the freezing point depression problems.